Hello everyone and welcome to the day 27 of the Jamb Physics in 40 days series. To those of you who have been part of the series from day one, we want to say a big thank you to you. Thanks for the love and support, for always making it a date to be a part of the series daily, dedicating the time to learn with us. You are the real MVP. Thank you very much. And also thanks for always liking the videos and sharing the videos. Thank you so very much. And if you're new to the channel, well, this is Jamb Physics in 40 days, brought to you by Oyalen, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you should be able to get all the necessary skills and tools that will help you ace Jamb Physics. So peradventure, you are preparing for the next Jamb exams, and physics is one of the subjects that you have selected in your subject combination. Then believe me, this video is specifically made for you. Because what we have done is, in each of the videos of the series, we've been able to look at individual topics that are in the Jamb Physics curriculum, and then we give you a crash course to it, tell you what is expected of you as a candidate writing the exam as regards those topics, and then we go on to solve past questions on those topics while handing tips that help you answer questions with higher accuracy each time. So you see, you do not want to miss any of the videos in this series, so please check out the video from day 1 till the end. This is day 27, so you really want to look at it from day 1 and follow it progressively until you get to the end of the series. And also please ensure that you are subscribed to the channel. That is your own way of assisting us to continue to make more helpful content like this. So please take a moment, click the subscribe button and the notification bell icon so that you get alerted every time we put out a new content. And also please help us like the videos and also share them to your contact list, because it is our goal to ensure that we reach a wide range of audience that are in need of helpful content like this, and you can help us achieve this. And the way you do this is by sharing all of our content with those on your contact list, and ensure that you tell them also to subscribe to the channel and also share to those on their own contact list. And also, if you have any question at all, whether it's on what we are doing presently or it's on anything you found during your study time that you would like help with, please drop those questions in the comment section of the video, and I promise to always attend to all of your questions. Please ensure you put the questions. We will definitely attend to yours. And I also like to introduce you to an app that helps you even get better as you study. The app is known as the Exam Fund app. The link to download is going to be added to the description box of this video. Please click the link to download the app. The beautiful thing about that app is that it infuses fun into your learning time, so it's not just going to be a drag to you. You get to enjoy yourself even while you learn, because it's created in a way that you answer questions at different levels, and then you get to score points as well as earn some money while you learn. So it is not just a fun experience, it is also a rewarding experience when you learn with the Exam Fund app. Thank you so very much, because you are doing this already. I trust you're going to click the subscribe button. I trust you're going to download the Exam Fund app. Just join us as we continue to make your learning experience even more rewarding. Now, to go to the business of what we have for day 27, the topic we're looking at today is dispersion of light and colors. Now, this is also under the study of waves, and but we are taking it a little further this time around. Now, what is expected of every candidate regarding this topic by Jamb is that you should be able to understand the dispersion of white light by triangular prism. Now, although originally observed by Sir Isaac Newton when he saw white light beaming on a triangular prism, thereby creating a spectrum of colors. That is what was now further studied. What he discovered from that observation was that white light actually constitutes, what we know as the visible light spectrum, consists of multiple colors. Now, if you remember from what we know as the electromagnetic wave, we have what we call the Revox G, that is radio wave, microwave, infrared, visible, ultraviolet, X-ray, and gamma ray. Now, the visible light spectrum under that electromagnetic wave spectrum consists of multiple colors. Now, those colors there represent the different wavelengths that you have in the visible light spectrum. Now, when you pass that into a triangular prism, what normally occurs when light passes through a prism is diffraction, right? So as white light is diffracted in that prism, because of their different wavelengths and the way they react when they are diffracted, when they are refracted, I mean, when white light is refracted, the red pigments there, the red color, is the one that is refracted the least. So as a result, it does not bend as much compared to what we have in violet. Now, the violet color is going to be bent the most. So as a result, you now see that widespread of colors giving you what we know as the ROYGBIV, or the colors of the rainbow, where we have red, orange, yellow, green, blue, indigo, then violet. These are the different colors that are present in white light when it is refracted by a prism. Now, this is the same thing that happens in our sky. The white light that is coming from the sun is refracted by the multiple water molecules that are in our atmosphere. So because of the water molecules in our atmosphere, we see this white light bend. And because the colors that are closer to the end are the ones that have the longest wavelength. That's why you see blue, indigo, and violet tend to spread more. And this is why our sky appears bluish. You see that it is close to even purple when you look at it at times. So it's between blue, indigo, and violet. That is how it spreads. So that's why we see that our sky appear blue. If you get to the atmosphere there, you see it is not actually blue. It is not in that color at all. But it's as a result of refraction, or what we call the dispersion of white light when it passes through prisms. And this is the same thing that happens sometimes during the raining times when white light passes through the raindrops that are in the sky. It causes it to also spread out or disperse to give us the different colors of the rainbow. So anytime you see a rainbow now, you have a better understanding of what it is. It is as a result of dispersion of white light. Now, another thing that they expect is that you should understand the production of pure spectrum. Now, when we say a particular spectrum is pure, it means that the constituent colors in that spectrum do not overlap. You can see them clearly. So whenever you pass the white light through a triangular prism and it creates distinct colors and you can see their boundaries clearly, what you have there is called a pure spectrum, when the individual wavelengths do not overlap each other. And then by the time they start overlapping, what you have there is an unpure or impure spectrum. Okay, now they also expect that you should understand what is color mixing by addition and subtraction. Now, at this point, some students get confused. Now, there's what we call the primary colors of light and primary colors of pigments, or what we know as primary colors of colors, right? So when it comes to light, the primary colors of light are red, green, and blue. But when it comes to pigment, they will call it the red, yellow, and blue. But it's actually called cyan, magenta, and yellow for the primary colors of pigments. Now let me explain this. So when we're talking about the primary colors of light, the light exists in three major colors: the red, the green, and the blue. And by additive mixing, we can get what we know as the pigments that we now see maybe from natural objects like leaves, dyes, and the likes. So like when you mix red and green together, you produce green, the yellow color that we know. Red and green will give you yellow pigments. And then when you mix green and blue, you produce what is known as cyan. Now, cyan is just like blue. It's just a faded version of blue. Now, blue and red is going to produce the magenta color. And by the time you mix the three primary colors of light together, you will get back to having white light. Now, by the time you get to pigments, the primary colors in pigments are cyan, magenta, and yellow. And by mixing, you can produce blue, green, and red again. When you mix cyan and magenta, you get blue. When you mix cyan and yellow, you get green. When you mix magenta and yellow, you get red. Now, to produce other colors, such as, like, for example, if you want to produce purple color, there are also mixtures that you can have that gives you those kind of colors by mixing your regular pigment with the primary colors of light. You can also produce things like purple and the likes. Okay, so but as far as the primary colors go, please do not mix that. For light, it is red, green, and blue. For pigments or colors, we have cyan, magenta, and yellow. Now, you are also expected to be able to explain how rainbow formation occurs. I have mentioned that while talking about dispersion of light. So once again, for clarity, when white light passes through water drops that are from the rain, it disperse into the different colors that are in white light, such as red, orange, yellow, green, blue, indigo, and violet, which forms the rainbow arch that we see in the sky when it is raining. And then finally, they expect that you should be able to describe the sources and uses of various types of radiation. I did mention them briefly earlier. When we talk about electromagnetic radiation, we have them as radio wave, microwave, then we also have the infrared, we have visible, we have ultraviolet, we have x-ray, and then we have gamma rays. So most times you just write Revox G, but there's a microwave in there. So microwave and radio wave, they form the same group like that. They are also radio waves because they are used for transmission of message via radio waves like that. So radio wave, microwave, similar. We have infrared, like colors that you get from hot objects like that. Then the visible light spectrums, that is visible light that we see, which gives us colors that I've mentioned here, the Roig beef colors. Then we have the ultraviolet, which is also a very ionizing wave, We have the X-ray. Remember that ultraviolet can actually be used to kill germs, right? And then it can also be used to view during the night time if you want to create like scopes that will help you see at night time, night vision scopes. You can use the ultraviolet wavelength. That is what is used most times in Natural Geographic Channel when they are checking out the jungle or Serengeti at night times. And then we have the X-ray, which helps us to see the human bone. It's used in medicine to discover where there is a fracture in the human bone. And then we have the gamma ray that can be used to treat even cancer cases by what we know as exposing a person to radiation to kill cancer cells. Now we have the one where you use chemicals, that's called chemotherapy. But when you use radio wave, that is radiotherapy, they use the gamma rays to do that. So you see, they are very useful in their various with their various frequencies and wavelengths. So you should be able to list these various radiations that I've mentioned and also tell their functions or their uses in physics. So having gone through this crash course, it is important that I mention to you that this is not as deep as it should be. I'm just telling you these details as it is what is expected of you when you are taking the Jamb exams. Now, we expect that you should have covered these topics as a whole, but if your knowledge on this topic is not deep enough and you like more, you would like to learn a little more about dispersion of light, please check out the video on our channel where we give it in greater detail. It's part of the playlist that we have on our channel where we discuss dispersion of light in greater detail. Trust me, it is loaded, and if there's anything I've missed at all, it is definitely in that video. Please ensure you check out the video, and also don't forget to share it amongst your contact list. So having gone through this, now we'll go and look at some past questions on this topic, and then we solve them. And I'll also mention some of the tips that you should have handy that will help you to answer questions on this topic with greater accuracy each time you find them. So please get your materials ready and let's solve some questions. In sunlight, a blue flower looks blue because we see the flower by the color it. Now, this is not limited to just flowers alone, but basically everything that we see with our eye. Now, our eye is able to observe colors in the visible spectrum based on what it perceives from the object that it is set on. Now, the eye itself cannot create colors, okay? So what happens is that whenever the light shines on the object absorbs all that color spectrum and is only able to reflect the one that is the color of that object itself. So for example, if something is red in color and then white light shines on it. Now remember, white light consists of all the colors that we have: the red, orange, yellow, green, blue, indigo, violet. So it absorbs all those other colors, and the only one it will reflect is the red, which is the color of the object itself. So because the object is red, it will reflect only red and absorb the other colors. That way, if you place the same object under a different color, like say blue for example, it's going to absorb the entire blue that is set on it, and then it will appear to the eye as if it is black or dark in color. I hope you understand what I'm saying at this point here. So that means for us to see the flower as blue, it means that it has absorbed all the other colors and is only able to reflect blue. That is why we are seeing it as a blue color. Now, other colors that do not exist among the red, orange, yellow, green, blue, indigo, violet that I just mentioned, sometimes as a result of the reflection of two or more colors that now mix. That's what leads us to additive mixing and creation of secondary and tertiary colors that we know. But in this question, because we are seeing that it's sunlight is white light, it beams on a flower, that means it's able to absorb all the other colors and it's only reflecting the blue color. So because it reflects blue color, the answer here is option D. This question says the angular dispersion of a prism depends on. Now when we look at dispersion of light by a prism, what it actually depends on is the velocity of the wave it receives, the wavelength of the different colors it is dispersing, and also the refractive index of the prism. So of all those options, the one that is stated here is refractive index. So the index of refraction only. So that would be option A. Now, this question can be a little bit of a trick question if you do not understand the line in the question. Now, the question itself says a mixture of blue and red pigments when illuminated by white light will appear. Now, what we are focused here on is the pigments. So when you mix paints, blue paint and red paint, what will you get? That is what will you see. The only way you are able to see it is because by the time the white light is illuminated on it, it is going to absorb every other color and reflect only blue and red to the eye, which will then be mixed together to produce what we see as purple. So in this case, the answer is option C, purple. Now, take note, if these were just lights that are mixed together, if you mix blue light and red light together, what you are going to get is magenta. Okay, so but because this is colors, as in paints, pigments are added together, is why we are seeing it as purple. So please take note, blue and red can either give you purple or magenta, depending on whether it is mixture of light or mixture of pigment. But because this is pigment, the answer is C, purple. When blue and green colors of light are mixed, the resultant color is now. In this case now, you see that what is mixed here is light, not pigments. So when you mix color of light, blue and green, what you are going to get is a greenish blue color that is known as cyan. So the correct answer here is option A. A narrow beam of white light can be split up into different colors by a glass prism. The correct explanation is that, now I did mention this at the beginning of the video, so you can pause the video and then try to pick what you believe to be the correct answer in this question. Then you compare it to the explanation I'm about to give now. So I believe you must have picked your answer. Now, if you have always been paying attention to our videos from the beginning of this series, I think about 2 or 3 videos ago, we did talk about the relationship between velocity of light, frequency, and wavelength. And we did arrive at speed of light equals the product of frequency and wavelength. And I mentioned that the frequency of a wave is determined by the source of that wave. And so it remains constant whether it is refracted or not. So when that wave moves from one medium to another, it will bend. Yes, and due to the difference in wavelength and speed, it will cause it to bend differently in that medium. Remember that the frequency remains constant. Now, and at the beginning of this video, I did mention that when white light passes through a prism, due to their wavelength, the wavelength of the individual colors in white light, they bend differently. And I mentioned that violet, which has the longest wavelength, is the one that will bend the most, while red will bend the least, right? So, and when you compare wavelength and speed, you see that they are related. When speed increases, wavelength will increase. When speed decreases, wavelength will decrease. It's only frequency that remains constant. So what you say in terms of wavelength, you can also say in terms of wave speed. So in this option, the correct answer is option C, which says different colors of white light travel with different speed in glass. So I hope you also picked option C because that's the correct one.
Rolling 3, 2, 1, go.
Before I go on to answer this question, if you're yet to be subscribed to the channel, please, I would like to implore you to use a moment to just click the subscribe button. It's just going to take a second. Hit the subscribe button and don't forget to hit the notification bell icon so that you get notified every time we put out a new content. And don't forget that if you have any question at all you'd like to ask us, please drop it in the comment section and we will definitely attend to all of your comments. And don't forget to always like and share the video. Thank you very much for doing this. Now, in this question, it says, which of the following is obtained when a magenta is mixed with green color? Now, we can easily get confused here because it didn't mention whether we are talking about pigments or light. However, from the answers provided, we should be able to arrive at an answer. Now, let's get this right. If we are looking at pigments, by the time you mix magenta and green, now magenta is going to absorb the colors red and blue, and then green will absorb all the blue that comes at it too. So as a result, when you view paints that are mixed, when you mix magenta paint and green paint, by the time you view it, what you're going to see is dark or black. But when you look at light, when you consider light now, we already have green here. Then you want to add it to magenta, which is actually blue and red. Remember, it's blue and red that makes magenta. Now, when you mix green, blue, and red as light, remember, this is in terms of light, okay? Now, what you get by mixing the primary colors of light is white. The result is always going to be white. So since we do not have black here, that eliminates the fact that it is not pigment. So that leaves us with colors of light, which means the answer here will be option C, which is white. So we go with C.
Camera rolling 3, 2, 1, go.
When a red rose flower is observed in blue light, what color does the observer see? Now, when you observe a red rose under a blue light, what happens is that the red rose is going to absorb all of the blue color and is unable to reflect any of it, because when you view a red rose under white light, what's supposed to happen is supposed to absorb all other colors and only reflect the red color, which is why we see it as a red rose. But because it's under blue light now, it will absorb all of the light that is incident on it and is unable to reflect any other color. Now, there is a little comma to this. Now, because red plus blue normally gives magenta, many students will think that the answer is magenta. But this is what you need to take note of. It's going to absorb the blue and reflect nothing. So if you are viewing it under blue light in a dark room, it's going to appear black. And then if you are viewing it under blue light, it does not mention whether it's a dark room or not. The best answer in that kind of a scenario, when dark room is not mentioned, is that it's going to appear dark. It's going to appear dark, not the black color essentially. So please take note of that. And when we look at the options here, we see red, blue, magenta, yellow, and none of them is correct. So the correct option here will be E, which says no correct option.
Rolling 3, 2, 1, go.
Which of the following is a secondary color? Now, to get secondary color, you have to mix two colors to get it, and it can be primary and primary or primary and secondary to give you secondary colors. Now, In this case, we have options A, which is blue, B is orange, C is red, and D is green. Now, the primary colors of light are red, blue, and green. And the primary colors of pigments is magenta, cyan, and yellow. So you see, when it comes to these, blue, red, and green fall under primary colors. Blue, red, and green. So the only one here that is not in that cadre for primary colors is orange. So that makes it a secondary color in this case. So we'll go with option B.
Rolling 3, 2, 1, go.
The production of a pure spectrum could be easily achieved using a. So let's just kill two birds with a stone with this question. When you're trying to produce a pure spectrum, you have to combine a triangular prism with two convex lenses. But if the goal is to produce impure spectrums, you'll be using a triangular prisms and two concave lenses. Okay, so in this case, since we want pure, that will mean the correct answer is option B.
Rolling 3, 2, 1, go.
Before I answer this question, if you're yet to be subscribed to the channel, please take a moment to click the subscribe button and the notification bell icon to be part of this family that makes your work a whole lot more easier and fun. Please click the subscribe button and also the notification bell icon, and do not forget to like and share the video so that we can reach a wider range of audiences that are in need of content like this. And if you have any question at all you'd like to ask us, don't forget to drop it in the comment section, and we promise to attend to every one of your questions. Thank you very much. Now, in this question, we see it says which of the following pairs of light rays show the widest separation in the spectrum of white light. So let's look at what the white light consists of. White light consists of red, orange, yellow, green, blue, indigo, and violet. Now, when you arrange it, this has longest wavelength, and shortest refraction. And then by the time you get here, it is the shortest wavelength here and longest refraction. Now, what this means is that this one will refract the most, while this one will refract lesser than the others. Now, and we are now seeing pairs of colors, and we're asked to find the one that has the widest separation. So if you consider blue and red, you see the distance between them here. It shows a wide separation. There's green and yellow, which are basically side by side. There's indigo and violet, also side by side. Then there's orange and red, which is also side by side. So the widest of these is red and blue. Now, please take note. You could find another question like this where they would now give you red and violet. That is the widest you can ever get. If you get red and indigo too, it's also wide. If you get orange and indigo, it's also wide. What matters is you being able to arrange it like this and see which ones are separated from each other the farthest. So based on these combinations that we have here is why the answer is blue and red as the widest separation. So we go with option A.
Rolling 3, 2, 1, go.
If the Nigerian flag is viewed in pure yellow light, which of the following sets of colors will be observed on the flag? Now, the Nigerian flag has the colors green, white, then green. Now, when you place it under a pure yellow light source, what will happen is that the green part of the flag is going to absorb all of the yellow light and reflect nothing back. So as a result, the green is going to appear black or dark under yellow light. Whereas the white part of the flag is going to absorb all of the colors and reflect all of the colors back as well. So which means when it is absorbing yellow light, it should be able to reflect the same yellow light back. So while the green part is appearing dull or black, the white part will appear yellow because it will be reflecting all the light on it, which is the yellow pure light. So what you'll be observing is black, yellow, and black, which means the correct answer is option C.
Rolling 3, 2, 1, go.
When light is incident on a object which is magenta in color, which of the color would be absorbed? Now, magenta is made up of red and blue. Now, the primary colors of light are red, blue, and green. Now, magenta equals red plus blue. So which means when you shine light to a magenta object, it is going to absorb green and is only able to reflect red and blue, which is why it appears to us as magenta, because it reflects back red and blue, which makes up to give us the magenta coloration of that object. So the only thing absorbed here is the green color, which means the answer is green only, which is in option B. Now you can practice even more by using the Exam Fun app. It covers a variety of subjects and you can infuse fun into your learning time by using the app. Trust me, it is a very interesting app to use for your study, and what makes it even more interesting is the rewarding part of it, which is the more you play, the more questions you answer, the more you earn as you learn. So please click the link in the description box of this video to download the Exam Fun app today. And don't forget to like and share the video, and if you are yet to be subscribed to the channel, kindly click the subscribe button and hit the notification bell icon so that you get alerted when we put out a new content. I want to say a big thank you to you for following the series so far. The series still continues. I'll see you in the next video.